We're going to talk about conversational agents. I suppose everybody has tried conversational agents, and they're usually pretty dumb because the great reason is why. I mean, we have LLMs, and that is because if you cannot control it, it's very, very scary. They will sell you plane tickets that don't exist, or they give you discounts, and that was the one that I think Air Canada got in trouble or something. So what we got to talk about is we get all this knowledge. How do we apply this in tasks? So our speaker is Harshit Joshi, and he is a second-year PhD student, and he also has a very strong background in systems as well as AI.
Thank you, Monica, for the introduction. Now, building on what George has built with SEQL, I want to show you that how can you create trustable agents and which can interact with knowledge, and then they can help in accessing performing tasks, like help users in performing tasks. So let's look at why do we actually need controllable dialogue agents? So I'm sure all of you must have had this situation where you call some airlines or some customer care service, and then you are just talking to the agent on call, and you're like, oh, hello, I need this, and then they are unable to resolve any of your questions, and at the end you just say, give me the agent, and nothing happens, and that's and then you just give up, or then you end up sending them a mail, and it's not a very pleasant experience. So if we could actually create a reliable and accurate assistant to help you with that task, this will make the work way easier for your manual human assistants. Plus, it will make it you'll provide a lot of capabilities, or it will be a very pleasant experience for the user itself. So controllable chatbots can save a lot of time for stakeholders and to assist the customers that you have. Now let's look at some of the existing commercial virtual assistants that are out there, which use function calling. So function calling is when you have already defined some functions and you just need to fill in the parameters, and how do they currently work. So for example, if I ask how's the weather at Stanford, the current commercial assistants will tell you, oh, they can perform this task pretty easily because they have a function for what's the weather. They'll take in the parameter, what is the location, and it will give you a very good answer, which is Stanford's temperature is at 66 Fahrenheit. But what if I ask a question can you book me a flight for Miami? They don't work that well. What they do is since they don't have this capability, they just do a search result and just give you a bunch of results, but they cannot assist you any further because they don't have this notion of mixed initiative, where if the user wants to do some new task, they can help you in completing that, providing you knowledge, and then taking you through the whole journey where they can actually be useful. So we see that the existing commercial virtual assistants, they cannot help you in performing such tasks. So let's look at what actually happens with these commercial agents and how do they work, and what is the reason behind why they don't work. So we see that all the traditional commercial agents, they rely on dialogue trees, where how it works is you first define the intent of the user. Based on this intent, you map it to specific actions that the agent can take, and the developer of these assistants, they have to manually hand code oh, if this is the intent, then you have to perform this task. And this leads to this works when the user is responding with expected answers. But what if, let's look at this example. The assistant says, hello, how can I help you? The user says that, oh, I'm looking to book a restaurant for Valentine's Day. The assistant then asks, it finds oh, what is the next question that I should ask? And then it says, what kind of restaurant are you looking for? And if the user gives some restaurant that they're looking for, it works pretty well. But what if the user says, oh, I don't know, what do you recommend? In this case, if this is not encoded in the agent's dialogue tree path, you won't get any answer, and the agent will just simply break. Now, so these dialogue trees kind of agents, they have their pros and cons. The good thing about them is that you have control over these conversations. That's why they are being used commercially. But there are several disadvantages to these agents. So for example, they are not very expressive. They, as I mentioned, that they rely on intents, and they use the slots and intents and slots, and these are very limited because you have to manually hand code each of these. So for example, if you have a question like, what are the top 3 restaurants near the airport or the fisherman's wharf, these dialog trees will generally fail. Now, the other reason why they are not good enough is like they are tedious to make. You have to like create all these paths, and you cannot always come up with all the questions that the user might ask. And then finally, they are like very fragile. If anything that the user says that it cannot handle, it will just break and it will say, oh, can I help you with something else, as we just saw in like the previous example. Now, this is a very interesting thing. So we all know OpenAI, they have built ChatGPT, everyone is using it, but still even for their own customer service assistant, they use a dialog tree-based agent, and they are not using LLMs for this matter. Like the question is, why aren't they doing that? The reason is, so as Monica just mentioned that this happened with Air Canada, they deployed this LLM-based agent, and it just promised a discount to a person, to one of their customers. So we know that what are the drawbacks of using LLMs in these contexts, but LLMs are good as well. They can help you in navigating questions that you haven't anticipated. They can still help users in answering those questions. So let us see like so some of the drawbacks of the LLMs and why do they do these there are like 2 main drawbacks. One is they cannot always remember what the user said in the conversation. And the other one is they are unable to adhere to the instructions that the developer is providing. And the way that this memory issue is like solved currently with the existing systems is you can either provide the whole conversation in the prompt or the instruction, you can provide the last end conversation turns, or you can summarize the conversation and then provide that to the LLM system. However, all of them have some drawbacks. So when you provide a lot, like the whole conversation, if the conversation is too long, the LLM is unable to contextualize its response. So there are like studies done by Stanford which show that if you have a lot of instruction in the prompt, the model only looks at the initial text and the text at the end, but ignores the text that is in the middle. If you are providing the last end conversation, then definitely it is not looking at the initial conversation turns, and it might miss out like on some of the information. And finally, if you are summarizing this conversation, the summarization might just leave out some important information because the summarization model does not know what is actually important for the task. Now, as I mentioned, that the other drawback is they cannot follow instructions. Now let us look at like why can they not follow these instructions. So one reason is that the natural language is ambiguous. And when developers want to provide control over some agents, they would prefer rather having a formal language where they can specifically say that, oh, this is exactly what you want to do, and that is much more clearer for the agent. But the question is that LLMs are good with natural language, and when you provide them formal statements, they cannot actually execute them or run them. So how do we give this capability to a dialogue system or a dialogue agent where it actually understands what the user wants to do? Now, the other drawback is like as similar to the one with the memory issue, which is when you have multiple instructions, the performance usually goes down. So in like our internal tests, we have seen that if you provide about 5 to 6 instructions, they work good. But if you have like, let's say 10 or 20 instructions in your prompt, then it won't like follow all of them. So we have seen like function, as I mentioned, and I've already mentioned that people have used function calling. People have also tried to use function calling with LLMs. However, one of the key difficulties in using function calling is that they cannot compose task requests and the knowledge queries. Now, let us look at like what a task request and a knowledge query mean. So for example, if I want to say, I want to book a romantic restaurant in San Francisco on Valentine's Day, this is a request for booking a restaurant, but it also has a knowledge query, which is I want to look for some romantic restaurants in SF. So what ideally we would want to do is like search for romantic restaurants in San Francisco. Then we might want to ask the user for confirmation for which of these restaurants do you want to actually book. And then we can go on to completing the task, which is book it on the Valentine's Day, which is actually today. And so we see that if you just have a function calling, you cannot do all these 3 tasks at once. because there you are just filling in parameters, and it does not involve mixed initiative, which is asking the user some question, then the user responding, and then taking all that into account. So now let me just quickly go over the challenges that just summarize all the challenges that we have already seen. So the first one is, how do we provide the developer the control over the knowledgeable and the responsive agents that we are creating? How can we provide support for knowledge bases such as SEQL or graph queries, and then embed them in these task requests? And finally, how do we create a dialogue system which remembers all the information that you are mentioning and uses that to contextualize its response and help you in completing the task? So at a very high level, let's see what does a controllable chatbot looks like and what it should do. So the first thing that it should do, it should always listen carefully to the user. We have seen this in other traditional chatbots where they would just be asking you for answers. If you don't give them answers, or if you, let's say we are in a banking situation and the agent asks, and the user asks, oh, I want to transfer some money to some other account. And if the agent asks, how much money do you want to transfer? And the user says, oh, how much money do I actually have? The agent here was expecting that you'll give some numeric value, the amount to transfer, but the user is already asking oh, how much money do I have, so that they can decide how much money they want to transfer. The agent won't be able to understand this query, and it will just simply break. So you should always listen to the user's query, first work on that, and then respond to the user. The second important thing is, how do you interpret all this information? You want to extract information about the request that the user is asking for, the location or time, and every other detail that the user has already mentioned, so that you can provide with better assistance. The third one is, you would want to always check your knowledge bases before answering to the user. A lot of existing work, or the research work that has been done, it has only been it only contains task requests. It does not include knowledge bases. And the other work, they only contain the knowledge bases, and they don't have the task requests. So here we want to combine both of them together. Finally, we have some predefined agent policy, which the agent always follows. I'll show you later how do we enforce this agent policy, but this can be modified by the developer as well, and it helps you in the developer can define, oh, when do you actually want to provide a discount, and when do you not want to provide a discount. And finally, it should respond to the user in a natural way. It should not be very robotic. It should be contextualizing all the information that it has already gathered. So how do we enforce all this? We have a declarative script. So you can think of so we call it Genie Worksheet. You can think of it as a sheet that you could provide to any, let's say you are providing this to a human assistant, and they can understand, oh, so there you have the student task. So this is an example from a ticket submission portal, and here you can see there are some student tasks, such as troubleshooting, asking for leave of absence, or asking about the test credits, and we have these natural language description about it. And then at the end, we have these WS action, which are actions that the agent can perform. And so this is a simple worksheet where you can describe what the agent should do. So this also allows for composition of knowledge queries and tasks, because there are two kinds of worksheet that we have. Some are worksheets which ask for questions from the user, and then there are knowledge bases that you can integrate, which can be used by the agent to answer questions. And finally, the third use case of having this Genie Worksheet is all the information that you have over here. The agent always keeps track of the information provided by the user. So for example, if the student is asking for troubleshooting, and if they have some extra details to provide, it will always keep track of those in the conversation. And that way, it does not have to keep the whole conversation with itself when it is performing or responding to questions to the user. The second thing that we have is a Genie runtime. So what Genie runtime does is it takes this declarative script that you have already written in a spreadsheet and converts them. You can think of it converts them into programs, small Python programs, and then it will be able to execute them as the user says something. So as we can see in the previous slide, we have the user task, it has student tasks, troubleshooting, extra details, it has some other functions, and in this is like this is a Python snippet which also contains this is for the restaurant booking task, where it has like you have book restaurant and then you can define your databases as well. Now, how does Genie runtime actually handle? So Genie runtime helps you with the memory issues that we already talked about and how to help with the instructions. So the first thing that Genie runtime does is it stores all the critical information in its active memory. So it just keeps it in its runtime system, and it never loses that information. Second thing is it runs all your knowledge-based queries and runs the APIs to fetch information for the user, and finally submits an API call to complete the task. The third thing it does is like all the information that has been provided by the developer as like which actions to take if they want to manipulate the dialog state in some way, all that is executed deterministically by the agent, and it can be modified easily if you want to change it. And these three things help with the memory issues that we have talked about. It makes the agent more helpful by providing you answers to different questions. And finally, it controls the way that the agent should respond, and it does not go off the script. Now, we implemented this system for our course enrollment assistant. Yesterday, Monica mentioned that how we used the course enrollment assistant, where students have to enroll into courses, and students, when they have to do this, they have to ask several different questions. For example, what kind of courses are offered, what are the different departments, specializations, which courses will help them in completing their degree requirement, and finally also asking questions such as what are the ratings, reviews, and what grade they can get. So we worked on like how can we create an assistant for this, which can be helpful for the students in like answering all these questions and then enrolling into courses. So let's look at one of the examples. So if the student says that I'm a sophomore studying CS and I want to complete my significant implementation requirement, what are the options that I can take, which require like least amount of work? And if you ask such a question, if a student is manually doing this, they will have to go through all the requirement sheets. At Stanford, we have Carta, which provides the information about how many hours it will take you, what grades you can expect, and all these sort of things. And it becomes a lot of work. So what our agent does is it will just give you the list of all the courses that are there. So for significant implementation, it will suggest you, oh, these are the 3 courses that I found, and all of them have average hours spent at the end. And it will provide you all that information. It can then the user can ask like follow-up questions. So for example, great, when are these courses offered? And you get all the information using the great system that George built, SQL. It can answer you questions like what are the timing, what are the dates, and these sort of. You can also sort the answers by course request. So these are like just simple SQL queries. But what Genie helps with is like it just keeps the agent on track and helps you in going through all these different kind of questions that you can have. It can also, so this is an interesting example. So for example, if the user says, oh, I want to take a letter grade, what is the maximum unit of units I can take it for? So here you can see that the user is asking arbitrary questions that you can potentially model in a dialog tree, but then these just exponentially increase. And here in our worksheet system, we just define it once in like 4 different sheets, and that's done. The agent automatically answers all these questions. Then after doing this, let's move on to some results that we see. So we are looking at the results on some static data sets. So these are traditional academic data sets where they have slot value pairs. And we see that Genie works really well with GPT-4. It outperforms all the baselines. It outperforms Llama 3.1 as well as GPT-4. And we can also see that Genie also works pretty well with open source models such as Llama. And it beats the GPT-4 Turbo with function calling and with function calling. Now, let's look at, as a whole, what Genie can do. So Genie, unlike the LLM function calling systems, it is reliable, it is controllable, and expressive. And unlike dialog trees, it is actually helpful, it is robust, and it is open domain that you can have like any number of tasks in the worksheet, and it will be able to solve all this. It will be able to assist the user with all those tasks. So what we did we did some evaluation. We created 3 prototypes. We already saw a worksheet for the ticket submission portal at Stanford. We had 3 tasks over there. Then we also tried out with the Yelp restaurant reservation, which has a huge database. And then finally, the Stanford Course Assistant, which has 4 different tables with multiple rows and data from last 3 years. And then we evaluate this in the real world setting with like 62 users. And we see that for all the domains as summarized here, the GPT-4 with function calling is only able to assist the users or like completing the task in just 21 or 22% of the cases, whereas Genie helps in almost 83% of the cases. Some of the interesting insights are, so when are the cases when GPT-4 sort of works? So we can see that in the restaurant domain, which is so it is a domain which is there in a lot of static benchmarks or academic benchmarks. And hence the performance over there for GPT-4 is like relatively better than in other domains. However, we see that ticket submission and course enrollment are 2 completely new domains for GPT-4, and it performs miserably. So for like ticket submission, it has a goal completion rate of 0, and for course enrollment, it has a completion rate of 10%. Now, here's an overview of how actually Genie works and how you can use it with your system. So Genie takes this declarative specification that you can define, then you provide the database that you want to use, you provide the APIs that you finally want to call, and some examples of like how do you want the system to interact with the APIs. And finally, you can have like a smooth conversation with the Genie agent. So now let us look at like what else can we do with Genie agent kind of a system which can help you in performing knowledge-intensive tasks. So I've already shown like 3 examples, and these are also there in our preprint that is out, which is for restaurant reservation, your course advisor, and then ticket submission. So last quarter, Monica had CS224V, her virtual assistant course, and we had students who worked on different kind of agents. They created 4 new agents using this. One was for writing grant proposal, where it interacts with the database, which contains a list of a lot of grants that you can apply for. And then it provides specific enhancements on how do you want to write a specific grant, what are some requirements for that. And the agent helps you in writing a proposal which you might not be aware of, like what are the specific nitty-gritties of. Then there were like a drug price negotiation bot. There was a travel booking and planning bot, and a very cute dog adoption bot. Now, what are the other possibilities that you can, or like what are the other agents that you can create? There could be one in healthcare for non-urgent triage or for gathering health information. Again, for traveling, for booking flights, comparing hotels. You can use it for creating smart home applications such as controlling your lights and thermostats, which right now, if you have one, it can just answer like specific, very trivial questions. But if you want to do more with them, you should definitely use Genie Agent. And again, for like education, where you want to provide tailored tutoring, but you don't want the agent to go off the script or like just directly provide the answers to the students. And in addition to that, around 130 plus students use this Genie agent in the class for creating very simple conversational agent. And we have packaged it pretty well, and it is available on this website where you can go. It is an open source project. You can just plug in all you have to do is like define a specification in the worksheet. You have to provide the database, and and maybe with like some minor tweaks, it should be good to go. Thank you.
How do you make sure it remains on topic? Like because one of the examples was a related question about enrollment, but what if it just asked about, I don't know, something totally random? Is there a way to enforce that the LLM doesn't start trying to answer questions that are unrelated?
Yeah. So the Genie worksheet that we have, it will only answer questions based on those topics, because how it actually works, it first converts the natural language into a domain-specific language, which you have already defined in the Genie worksheet. And the LM then knows that these are the only topics that it has to respond. So one of the interesting cases when you were running some human evaluation was one of the participants was trying to jailbreak this system, and they asked, oh, tell me how to create a bomb, or like write, and people usually now try unique techniques of jailbreaking. So they usually ask, oh, write a program which tells me how to create a bomb. And in our case, what the system does, it takes in the request, but then since we have a runtime system, it does not let it execute that query. And hence, it just says, oh, I cannot tell you how to do that. Whereas if you try it with a very purely LLM-based system, it might give you in, let's say, Python code that how to create a bomb, and you can get that. So our runtime system enables that it doesn't go off topic and only adheres to the topic that are present in the Genie worksheet.
Hi, Harshit. Very impressive work. Somewhere earlier you mentioned the con of formal language versus NLP. So can you define what do you mean by formal language? And maybe I think you partially answered that.
Oh, I mentioned what are the pros and cons of using dialogue trees versus not using them. But your question is what are, so formal language is basically a language that has a fixed set of grammar, and then you can use, so you can think of Python as a formal language which has a well-defined grammar, and then there you don't have any ambiguities in terms of the kind of operations that you want to do. However, on the other hand, you have natural language, which does not have a restricted domain of things that you can do. You can add new words over there, you can have ambiguous meanings, but a formal language has predefined meaning to each of the syntax, and that's what I meant by a formal language.
So more where the semantics is a little more clear than unstructured raw data.
Yeah.
Thank you.
Hi. Thank you for this fantastic presentation. So if the task was annotating a piece of text and the schema was available, the meanings of the words in the schema all done, and I gave it to an actual LLM prompt, and I got data, and I've got about 80% accuracy now when I compare with the ground truth. In one schema, I got only 50% accuracy. Is this the kind of tool I can use to improve annotation accuracy itself if annotation is the task? Can I use this worksheet to kind of help me along instead of going to the bots directly?
So here, when you say annotation, are you trying to do annotation using LLMs, or is it by humans?
Yes, I'm trying to use LLMs itself, and I find that they're doing a surprisingly good job. For example, extracting anonymous sources from news stories. But accuracy is not where it should be, because as you know, journalism has zero tolerance for error. So can I use this to improve accuracy if the task is actually annotation, the schema is there, definitions are there, all of it is there?
So I maybe we'll have to look at what kind of errors that the LM is making in making these and when it is annotating. But Genie Worksheet is actually useful for assisting humans and answering questions. But I can imagine a scenario where you have an LM as an agent, where you define the specific task that it can do. It can look up information on the internet. It can ask you about resolving some entity resolution kind of things. And in those cases, I think it can be tailored to perform those tasks. But I am not sure how well it will perform. It will definitely perform as well as it was already doing. We'll have to see how it can improve upon that. But I can imagine cases where you provide additional capabilities, such as looking for news, searching the internet, or looking at some database to acquire knowledge and then answering this.
Really wonderful work. So I just have a tiny question about an open-ended research task like research ideation. where we really want to balance creativity with minimizing hallucination. I wonder what are your thoughts for building an agent that can handle the task like that?
I think like research idea generation actually is one of the things. So LLMs hallucinate, we know that, and I think hallucination is good in that case. That when it is coming up with idea generation, and there you don't want to restrict it to a script or of some sort. So in those cases, I think like hallucinations are good. You would rather want them to like explore new things and new information that might be out there. And I feel like in those cases, we might not want to like control them and rather just let them think more. We can enhance their hallucination in these cases by maybe providing new details, new information from like our databases, but it would be better to just let them run free.
I can be quick.
Quick question.
Yeah. This was really great. So I do human-computer interaction AI, and we have a paper where we try and give people access to modify the prompt. How would you allow users with no programming to actually modify the prompts, the LLM, to kind of make it more relevant to them?
So in our work, the users never modify, or even the developer never modifies the prompt. They just have to provide some examples, which we are working on making it even easier for them to provide those examples, but there's no prompt engineering of any sorts involved from the developer's perspective.
Well, thank you very much. So let's, well, thank you all the speakers, and I also want to thank the staff that makes this workshop possible. Maybe let's give them a round of applause. And thank you all for coming. And there are a lot of people watching us over the live stream. And the live stream is recorded, and we will also make it available after this event. So thank you very much for a wonderful workshop. And I want to, again, thank our sponsor, Sloan Foundation. Doran Weber is the one who makes this all possible. And we got an amazing support also from HAI. All right, thank you.